So let me start off with introducing your panelists. On my left, I have Nick Schrock. Nick is the CEO, excuse me, way more important.
Big announcement.
And co-founder of Elemental, the company behind Dagster. Previously, Nick worked at Facebook, where he co-created GraphQL. Nick believes deeply in the power of well-designed developer tools to make engineers more productive, accelerate their careers, make their lives more enjoyable, and transform the organizations in which they work, which I think many of us do. So we've got some kinship. One thing that I did not know until recently about Nick is that he seriously considered a postgraduate degree in history before deciding to be a software engineer. Next, we have Prakalpa Sankar. Prakalpa is the co-founder of Atlan, a modern data collaboration workspace, which acts as a virtual hub for data assets, ranging from tables and dashboards to models and code. Atlan enables teams to create and discover a discovery and context layer for all their data assets. Previously, she co-founded the Data for Good company and economic forum tech pioneer Social Cops, which is behind landmark data projects, including India's national data platform. Fun fact, Prakalpa is the only Prakalpa in the world.
It's true. My parents thought of SEO before SEO existed.
Srishanka Das from Acral is here. He's the co-founder and CEO. Acral is the company behind the open source metadata platform DataHub in collaboration with LinkedIn. Prior to founding Acral, Srishanka spent a decade at LinkedIn building data infrastructure and data platforms. He also founded the DataHub project as part of his tenure there. And finally, we have Stephen Hillian from Astronomer. Stephen is head of data at Astronomer. And before that, he built machine learning platforms at a series of Silicon Valley startups, including Pivotal and Alpine Data. He's served up predictive models to clients ranging from ABC to Wendy's. And, as a fun fact, he's currently working on a translation of the corpus of Greek mathematical poems.
Yes, make sure to pre-order that on Amazon. Because it's,
I feel much less interested now.
I have a fun fact.
Oh, please.
I did not have a fun fact, but I was brave enough to interview a 10-year-old about metadata.
That is amazing. That is absolutely a sign of bravery. Now, metadata obviously is a key part of datasets, but not the only one. Datasets, I think we can all agree, are absolutely foundational to our work as data practitioners. We use that word all the time when we're describing our day-to-day conversations of projects that we're working on. There are a lot of different data tools that have independently converged on similar concepts, but like many of the concepts in the modern data stack, the exact meaning, properties, and capabilities of data sets often differs in subtle ways. And we see a lot of competing terms that are vying for attention as the critical artifact in our world. I absolutely believe that concepts like this will define the next generation of data work, and that the cornerstone of the modern data stack is a new set of tools and abstractions that map more tightly to the world in which we all work. So let me start off with an open question in the interest of disclosure. Can I have each of you describe a little bit about your project, your work project, and how you think that shapes your concept of a data set?
Yeah, I'll start off. So I work on Dagster, which is a data orchestration platform. And it grounds the definition of our definition of data set, because we view it as a data asset, which we'll get into. And we think that the data asset is fundamentally a software artifact that you should model in the orchestrator and be its source of truth.
Hi. So at Atlan, we sort of see ourselves as that collaborative layer for the data stack in some ways. And I think the fundamental thing that we believe is about diversity. Right? If you think about number on a dashboard is broken, I still remember this as a data leader myself. Cabinet minister calls me at 8 in the morning and says, number on this dashboard doesn't look right. And then I call my project manager, who calls my analyst, who calls my engineer. Takes like 5 different calls, like 8 hours to even figure out what went wrong. And the core to the data stack is this layer of diversity, right? Like diversity is never going away. Diversity in the kinds of people and personas, and diversity in the kind of tools that each of these personas are using. And so then if you think about what does it take to sort of achieve that collaborative layer in a modern data stack, we sort of think of it as how do you make these tools and people work well together while embracing the diversity, and sort of that is the. And we'll talk about why we think the metadata activation layer is why you do that. But that's sort of the approach that we're taking here.
All right. Shashanka and I work primarily on DataHub. It's an open source, the #1 open source metadata platform for the modern, postmodern, legacy data stack. And a lot of people don't know what a metadata platform is, and we'll talk about a lot of concepts here. But our goal really is to map every single data concept known to an enterprise in one comprehensive and understandable metadata graph, and then everyone prospers. So that's our goal.
So my project is sort of leading data science for Astronomer, and in fact, I was telling some friends just now, I got off a call literally before this meeting where we had a very contentious discussion about what the definition of a closed opportunity was, and also like monthly active use, things like that. And everybody is looking at the data team to define what those things mean, which is sort of an enviable position and also very unpleasant. So I was thinking that I'd probably answer the question, what is a data set, by saying, I don't know, ask somebody else. But I think that actually points at something. There's, I think, a dry definition of a data set, right? A collection of observations stored in some sort of digital format or something. But I think what's changed, if you actually see like this pickup in the use of the term data set around 2010, and I think that's sort of the rise of the data scientist, and the idea that the data set itself is like this locus of value that it didn't used to be. It used to be just this annoying thing you had to unpack and pass around from within one tool to the next. But now I think it's deliberately contentious. It's deliberately the focus of an organization because there's so much value in there.
Thank you. I think the notion of the way that we see the world affecting how we understand the concepts that we all encounter is very central. I guess before we dive much deeper into definitions, I wonder if you could each share a story from your past professional experience that you think most significantly affected the way that you have chosen to define the data sets in your tools today.
Maybe I can go first. So I actually did not start my life in data, or at least data as most people here define it. A lot of you folks are data engineers or data scientists, and so you're starting with data after it's got into the warehouse. But I started my life working on data as a database builder. So I was actually part of the LinkedIn data infrastructure team, and my job was Oracle is not keeping up with LinkedIn's traffic. We need a new data store, a source of truth data store. So I had to go build a MongoDB-like document-oriented database for LinkedIn to run the entire site. And so for me, a data set started out as a table in an operational data store. And then later on, I went on to build ETL for that distributed database, and I ended up also working on a change capture system, kind of like Debezium. It was called Data Bus. And I also worked with the Kafka team. And so I ended up spending a fair bit of time in the streaming ecosystem, and that affected kind of the understanding of a data set as something that's in motion and downstream of maybe the operational data set. And then the last 6 years of my time at LinkedIn, I was actually the tech architect for all of data platform, big data platform, that kind of stuff. And so I realized that actually what I thought of as data was something that the data warehouse team didn't even care about. They were talking about data sets and golden data sets and MicroStrategy dashboards and a bunch of these other things. And so that really expanded my definition of what is a data set. It's actually all of the above. Even a search index is actually a data set to a search engineer. But then as you go down the stack and you work with the metrics platform team that's actually producing metric data sets, there's like a bunch of more insights that's inside of these derived data sets. So that's kind of what has shaped my definition of a data set and DataHub's definition of a data set. We kind of talk about tables and topics and key value stores and metrics all as kind of data sets. And the thing that recently I've been thinking about the most is a view a data set? Because a view is code and it transforms a data set. So to an orchestrator, it could be something that is a pipeline that they're materializing. But then for a consumer of that view, they just look at it like a data set because it just gives them tuples. So I think that's kind of the most interesting part of where I think data sets are going for me personally and as a project.
Yeah, I guess I feel like my definition of an understanding of this world has evolved over a very heterogeneous career. So what you said really resonates about, I haven't spent my entire career in this domain. And, it's the heterogeneity that strikes me. And that's why we talk about data assets and how, and I kind of started out with the software definition, but what it really is anything where you capture information of the world in a durable form, where you can ask questions and make decisions based on it. So a data asset is really almost a decision-making engine, either directly in an automated machine learning system or indirectly with humans making decisions based on data. And yeah, just seeing I used to work in healthcare and surveying and talking to so many different users with the extreme heterogeneity of their use cases, all the way from machine learning, and that's why, again, I think the definition should be more general.
Ooh, I can go next. I ended up stumbling upon the world of data in some ways and self-taught myself data. So I started out saying, hey, there are these large-scale problems in the world like national level healthcare and poverty alleviation. They don't seem to be using data. It feels like they should. Let's go do something about that. And this was before the notion of a data team was really a thing. I think the word data scientist was, still one of the sexiest things back, and I think that article had just come out, right? And so it was very early in the world. And so we sort of started putting together these teams to solve these big problems out there. So, and what I ended up finding was that every time we would have the most successful projects, it was when we had these fundamentally very, very different people in the room. Like there was this one time where we had to basically figure out how to allocate LPG gas centers or clean energy centers to 80 million women below the poverty line. And in the room, we had data scientists and data engineers and machine learning engineers, but we also had a program manager who came from a political science background, who is like, hey, this is the way you should think about how these data sets should actually operate. Like, this is the wrong way that you're thinking about, building out this model, for example. And the core thing about this was just that fundamental diversity. Data operates at the intersection of technical and business. That's the core, that's the reality of data, which basically means that you need very different skill sets to make these projects successful. But that actually is our biggest strength, but also our biggest weakness. Because, you want me to? Okay. Can you hear me now? Okay. So that's also the biggest weakness, right? Because if you think about trust in a team, most other teams are built by people who know what each other are working on. But in a data team, when, a business analyst doesn't actually know what a data engineer does on a daily basis. And that causes like a breakage of trust in these teams when things go wrong. And so my overall thought process, and this has evolved into saying then, if diversity is the only reality in this team, how do we think about the core assets? In this case, a data asset. To a data engineer, what might matter the most is, did the pipeline break or not? Is the data updated? To a business user, what it means is like, what does annual recurring revenue actually mean? And these two people need to collaborate well together to actually make a project successful. And so that fundamental diversity is, I think, what is the only reality that in a team, and the way that we think about data assets or data sets sort of comes from there.
Yeah, maybe I have a story that echoes a few of those themes and expands on what Shashanka was saying. I was working with with Toshiba, high-tech manufacturer producing wafers of memory chips. And the wafer goes through the factory, the fab, and it's a multi-week, very sort of weirdly organic process. And out the other end becomes this disk of wafers, of chips. And you want to know if it's successful or not, crudely speaking, sort of a binary classification, good wafer, bad wafer. And all along that journey, you have thousands of sensors making pressure measurements, temperature measurements, and so on. And there are thousands of those being taken every millisecond or every minute, depending on the thing. So you've literally millions of sort of input variables, if you like. This sensor measured this at this time. that are potentially predictive of whether the wafer's successful or not. So Toshiba referred to this as the 6 million problem because essentially you're sort of regressing this binary outcome against 6 million variables, and that's not an easy thing to do, especially if you want the model that does that to reflect the current state of the fab at any given hour, say, because it's constantly changing. And these wafers, pulling them off early can save you millions of dollars. Anyway, so that data set, right, that the factory is creating was essentially a streaming data set of sensor information and then finally appended with the success flag. So from the point of view of the factory manager, this is a streaming data set. From the point of view of the engineer who's taking care of ingest, it lands in a H-based table, I think it was, a set of name-value pairs. But from the point of view of the data scientist, that's no good because that's just unwieldy, and also data scientists want everything to be a table, like a real table with lots of columns. So there was this process where you had to essentially do this sort of dimensionality reduction to still encode all of the information in the original data set, but make that useful to the data scientist, and then you make your prediction, and then that's revealed to the essentially back to the factory manager to say, this wafer failed for this reason, go and clean that machine. Literally, they would go there with a bottle of Windex or something and clean the machine. Anyway, the point is, right, this is exactly about this idea of a data set can be manifested at any single point as name value pairs, an H-based table, and a pandas data frame, whatever it might be. But it's actually the same data set. It, largely speaking, contains the same information. This idea that a data set can morph over time and can manifest itself to different people in different ways. And therefore, well, it's a little self-serving, but you need that sort of lineage component, right? You need this idea of how these things relate to each other. I think that's the key realization to me. One of the reasons I got interested in orchestration, because it's like, oh, you need to tie these things together. Yeah.
Stephen, that absolutely mirrors a lot of my experience as well, specifically this notion that like a data set changes a lot. And at the same time, I think there's a lot of discussion about versioning data sets and the need to be able to have immutable data sets and sort of change this notion of a data set transitioning into a notion of lineage. I guess what I want to do next is ask for everyone here to imagine a single pane of glass view of a data set. The ideal picture of what you need to know in order to be able to really understand and use a data set. And I'm curious for a couple of things. One is, what is there? Like, what do you see when you're looking at that pane of glass? And two, where do you go to get that picture?
Well, spoiler alert, you go to the Orchestrator. But I think just to vibe off what you were saying, to make the notion that it's the same data set as it flows through the Orchestrator, I actually fundamentally disagree with that. Because I think by the definition of a data set, it's where you encode understanding of the world. Effectively what's happening is data flows through these systems as you're changing your understanding of the world. And what's doing that is the code. It's like a human wrote code, and it changes the understanding of the world from, it goes from data set A, there's code, and data set B is different because there's understanding that's built into that, which is why we think that, our belief in the Daxter project is that, and we have a new product direction, additional product direction that really doubles down on this, that the canonical place to define an asset is in software. You write an asset in software, it declares you're intending it to exist over time. And you have a software artifact where you can hang off all the different metadata about it, anything about it, and there's one system of record for that. So what you want to understand is two things at the same time. One is the software definition of that data asset, and that's what the programmer or the developer or the practitioner declares what they intend the world to be like. And then simultaneously, in that single pane of glass, you also have a history of how that's been materialized over time. And having that duality in one spot, we think is critical, because that can capture the intents and like what the current state of lineage is, as well as, for example, the historical lineage, which has changed over time. So,
I completely agree and disagree.
Nice, let's go.
So completely agree about the principles, but you're going to go to Data Hub because that's the glass pane.
Can I?
But let me explain. I think The glass pane is really for humans to get essentially like a 360-degree view of the data set. I mean, a lot of us talk about customer 360, right? And I think for the metadata world, what we want to see is dataset 360. And what does that contain? It contains obviously the basic stuff like the name of the data set and the schema of the data set and where it came from and all of that stuff. And ideally, if you're living in the data mesh world or in a software-defined data asset world, you are declaring your data assets up front, which is awesome. So you get that. And that's the definitional plane of that thing. But then there's the operational plane of when things actually run and being able to get every single breadcrumb of not just the Daxter runs or the Airflow runs or the ML flow runs, but also the Great Expectation runs or the streaming Kafka Connect runs or the queries that are going up against the microservice instances. Just getting that operational plane integrated and then being able to move up that cognition plane into the business world, which is where the customer and the revenue and all of these models live. That I think is really what all of us are really trying to give to the organizations, a way to get not just broad, but also deep insights into a data set as an anchoring entity. The other thing that I wanted to bring up is we often get obsessed with the UX of it all, like the glass pane. We think of it as an iPhone-like experience. But there's also the developer plane, which is how do programs or code integrate with this pane of glass, and what does that look like? And I think there's basically this missing API 360 that is needed so that anytime in your Jupyter notebook when you need the schema of a data set, who are you going to call? Anytime you need business metadata in context, who are you going to call? And that I think is, for me, solving both of those would be great for the industry.
So I completely agree and disagree. So here's where I agree. I think that and we spend a lot of time thinking about this concept of a data 360, right? And so, engineer, when you onboard an engineer, you share a link to a GitHub repo, it has your code, your documentation, your revisions, everything in that same space. Why do, sales teams have a Salesforce account ID that they share? Why do data teams not have that, right? And so, as you think about context is about how do you get context from every single aspect of the ecosystem and bring it to create almost that unique data asset profile inside an organization. But here's where I disagree. I believe there actually isn't a single pane of glass for every single user. It isn't the same single pane of glass for every single user. Because context means very different things for very different people. Context for a business user is very different from context for a data engineer. The way these people want to consume context is also very different. Like, I'm in a Looker dashboard, I'm like, can I trust this dashboard? What does this metric mean? I do not want to jump into a different tool to actually get that context, right? Context for a data engineer is also very different, and the time that you're using this context, if you're using this when you're troubleshooting something versus you're using this when you're actually running an analysis project, that is the unique thing that actually drives the way people or users use this. So the way we think about this is, then if you can say, hey, Netflix has unique personalized experiences for each and every one of us, why can we not create that same sort of personalized contextual experience for every user? One element of this, the way we see this in Atlan, is we have this concept of personas and purposes. So very unique experiences for an analyst and engineer, but a marketing analyst and a financial analyst. But the other way that we think about this is we think about the metadata activation layer. Is one aspect of this is bringing this context and stitching together that profile. The other aspect is taking it back to the tools that people are using every day. So if you're using Looker every day, you should get the context right there in Looker. If you're using Daxter or Astronomer every day, you should get that context that you need to troubleshoot those pipelines right then and there, right? And so that's the final layer that we think of, which will actually, you don't need a single pane of glass. What you need is a better way for your team to work together. And so how do you make that happen? And that's where the metadata activation layer will hopefully reach its true promise in the next couple of years.
I agree with everything that everybody has said. Actually, maybe I won't try to make a broader statement, but I'll just say something super specific. Because in a way, this is the problem I wrestle with, and I was referring to in the my sort of intro, right, about sort of working with all these different departments and defining what an MAU is or whatever. And so I have a very boring answer to this, which is that I realize that it's important for my team right now to have strict and well-publicized definitions of the fields and the metrics and the KPIs that we create. And most of those, this will probably change over time, but most of them right now live in a data warehouse, a traditional data warehouse. Even the stuff that the data scientists use, they may create a model out of it that then scores, but even that largely is batch and will end up back in the data warehouse. So I insist that every time we create a data set in that warehouse, you add comments in the metadata that the data warehouse supports. It's created at the time that you create the data set. We've got utility functions that essentially in our internal Airflow implementation force you to do that. But it means that there's one source of truth and it's not removed from the data. It literally lives in the comments for the column in the table. So it's a very practical approach to defining these things, but there is one source of truth there.
So we've got this notion that there needs to be a source of truth. I think that we're clearly, I think, pretty roundly rejecting the notion in my question that there is a single pane of glass for where that source of truth is located, which I appreciate. And of course, I don't think I got to properly advocate for the notion that the single source of truth is your data quality framework. So let me just make sure I get that on the record officially here. The corollary to this question really is like, who's responsible for updating? Like, Stephen, I think you just said that it needs to be the responsibility of whoever is changing a system to update that definition, which I have to admit sounds a little bit like an unfunded mandate, right? We all insist that the person changing something produce better documentation, and yet the world is all about finding ways to make that easier to do. So, what characteristics do you think really define the responsibility for updating, and how do you make sure that documentation stays accurate in any kind of modern data stack?
Well, to put on my Proculpa hat, I thought that was an excellent answer, that it really is a multi-stakeholder problem. And I think one of the challenges of these systems is that they are multi-stakeholder. You have to think about how the different personas are going to interact. We really focus on the engineering problem, and therefore, from that perspective, the source of truth should be in code. We know how to deal with code review, we know how to version it, track it, etc. So, like for example, this is an example of like the comments should be in the column and co-located, the metadata should be in the warehouse. Totally agree, but I actually think the source of truth should be in software, and it should automatically be reflected in the data warehouse. So it's a question of like, all this information gets replicated all over the place, but I think the interesting question is, for each particular piece of metadata or data or whatever, is where is that source of truth from which everything else is derived? And so, kind of, whenever the engineer is in the loop, push it towards code. Then you get into the world of different contexts, which is more in Atlan's domain, of humans in the loop and workflow and all that stuff. And then for that aspect, it makes sense for that to be the source of truth and maybe to pipe it back to the other system. So I really thought your comments were super insightful about the different contexts that we work in.
I think you totally wore my hat. I don't have anything to add to that. I fully agree.
Who's acquiring who?
Yeah, that's right. The notion that that code is the definitive source is certainly I think that's a pretty provocative thesis in a very data-centric world. And so I guess before I dive too deep on that, I wanted to zoom out and think about what other kinds of metadata do you think exist for which there already is some clear emerging standard? And which ones do you think there is the most daylight between systems? Stephen, I guess I'm going to direct this to you, specifically with respect to lineage.
Yeah, I think it's difficult to claim, notwithstanding the excitement of the day, that there is a single sort of standard for metadata. What I think is true is that there are winners and losers, and that the set of winners that sort of bubble up, that sort of emerge, is pretty finite. There's SQL, there's Python, there's Parquet, there's sort of relational tables. It's a finite list, and it's the responsibility, I think, maybe of the orchestrators and the lineage providers of the world to sort of understand all those different interfaces and collect them together. So Nick's absolutely right. The orchestrator is sort of a natural, the orchestrator, the data catalog, these are all natural places for that information to belong. We don't have to pick or choose. But what we have a responsibility to do is to understand that there is this longish but finite list and understand that. But there is no single metadata standard. I mean, if there is, it's probably SQL, but it's not really metadata. So there just isn't one, and that's telling us something. It's like, don't force it to happen, you know?
And one of the things I've noticed, especially around this kind of source of truth debate, as well as the standardization attempts, is that while each individual producer of metadata is extremely confident about the metadata that it is producing, from a consumption perspective, you run into similar quality issues that you face in data quality. So for example, S3 might tell you definitively that a particular file lives in a particular bucket. But that doesn't tell you what the data set is or who owns it or things like that. And for that, you might need to actually kind of cohere your understanding of the glue catalog plus S3. And in some cases, you might also need to consult Athena, which has an external table reference to the same glue catalog. And so you've got different kind of producers of metadata that are very precise and opinionated about what they're saying about a subset of the graph. But I think there's a responsibility that falls to a standardization layer to say, does this data set exist and what does it look like? And so far, I think that responsibility has sort of fallen on the catalog or the metadata platform. And we can call it whatever we want, but there is the need for this kind of standardization layer. And so even if we follow a particular protocol in terms of emitting metadata, there still is a missing gap of saying the syntax is right and it conforms to a particular format, but where's the semantics and how do I standardize it for anyone to consume? And that, I think, is kind of an open challenge that all of us are sort of facing.
Well, I think we've covered a lot of ground. And I think from the very beginning, the question of what is a data set, one of the themes that I really heard from everyone here is that the data set is the thing that we can go to answer questions. Like it is however it is instantiated or manifest, it's the way that we can have a shared way of reconciling between different groups and stakeholders. I mean, I think we also, it sounds like, really are describing this notion that there is another data set, at least one data set then, that exists about all the other data sets, whatever form that takes. What I want to do now, as we wrap up here, is ask for each of you, we talked about the things that you all agreed and disagreed pretty vehemently with other people here. Can you just tell me what is the favorite sentence you've heard from someone else on the panel today?
Well, I already did it.
I can go first. Because that way, my favorite line will not get taken. So I really like the software-defined asset definition that Nick talked about, because it fits very closely with kind of what I would like the world to move towards, which is definitions are the source of truth, and you define it as close to the place where you're defining data itself. The world doesn't need bad metadata quality. We've suffered enough bad data quality as it is. And the more we can push context up into the developer's IDE, the better it'll be for everyone. Whether it's Daxter or DBT or like pick your favorite, place where you live, that's fine, but just do it there. And that, for me, that was kind of the best thing for me. But.
Thank you. That's so nice. I will double down on what I said about Prukalpa's framing of rejecting the framing of a single pane of glass and says there's multiple overlapping ones based on context. I thought that was very insightful.
Yeah, that was going to be mine as well. I think it's absolutely true. But so instead, I'll give one to Nick, which is this idea that the orchestrator is also in its own way the source of truth. And again, it's sort of self-serving, but I think that's really true. The data catalog or the comments in Snowflake, wherever it is, tells you what this is, at least according to somebody's opinion. But then the first question that any marketer is going to have is like, well, I'm not sure I believe that, or how did you calculate that? And you have to be able to go back and not just look at the lineage, but look at actually how the calculations happen to be able to verify that. So that's yours.
I'm going to say, actually, what Srishankar said about the concept of a data 360. And I actually want to take that one step further on what, I think there's something very profound there, right? Which is, can we learn from what other teams have been able to do? So if, there's good things that Salesforce did with sales teams, and there are good things that, Figma does with design teams. And so are there things that we can learn from other teams and sort of bring that into our, and not just, I know we talk a lot about engineering and how to bring engineering practices into data, but can we think about, there are actually things that business teams have done pretty well, and can we bring those practices into data? So that's
Thank you.
fine.
In fact, I think it's not just 360, which is a 2D concept, but it's actually 4D, because you actually want time, which is the other dimension, to actually understand the full context of a data set.
Well, thank you all very much for this conversation. It's been an absolute blast to get to be up here with you and to be in front of this audience. I'm really excited about what we've gotten to cover, and I think there's certainly a lot that we all get to go look forward to now as we build on these ideas and continue to build the modern data stack together and continue to evolve and hash out the ways that all of the parts interact. Thanks very much.